Hello student, once again welcome you all in this online session. Myself Samadhan Patil from JIT Engineering College Nasik, and we have started our unit number 4 vector differentiation. This is the third lecture, and today we are going to discuss some example regarding related with vector identities and irrotational and solenoidal field. In previous example, in previous lecture actually, we have started some examples and we have seen some basic concept about the vector differentiation. Okay, now today let us see the example. Before starting the actual topics, so let me introduce one more thing for you. So for more information about M1, M2 and M3, so just follow me on my blog, so that link I have now providing you. So http samadhanpatil17.wordpress.com. So why this is useful for you? Because it it contains, I have uploaded the syllabus of engineering mathematics 1, 2 and 3. Okay, from that I have uh, uh, uploaded on my blog. Okay, then second is unit wide notes for engineering mathematics 1, 2 and 3. So M1 and M2 are common for all branches, but M3, so branch wise I have uploaded the notes, syllabus, all that things on my blog. Okay, then assignments for practice also there, university and question papers are also there. Then MCQs for practice, this is very important. Okay, because all the unit wise MCQs already I have uploaded, so you just follow the blog so that you can find out all that things and take a help for all that uh, material for your study. Okay, so first example is for a vector field. Show that the vector field I bar is equal to x square minus yz I plus y square minus xzj plus z square minus xzk is irrotational. Find the scalar potential phi such that m bar is equal to del phi. Actually we have seen this in the previous lecture. We have solved this example how to show this vector field is irrotational. So we just left this part. So at that time I just told you, I have told you that we discuss this concept in the next lecture. Okay, how to find the scalar potential phi such that f bar is equal to del phi. Now today we are going to discuss about that topic. Okay, but once again let us see, just recall how to show the given field is irrotational. Okay, now consider to show the given field is rotational, what we have to show? We have to show this del cross f bar is equal to what? Del cross f bar is equal to 0. This we have to show. Del cross f bar is equal to 0. Now consider del cross f bar. Okay, so this is your del cross f bar ijk. Okay, dabba by dabba x, dabba by dabba z, and dabba by dabba, and dabba by dabba x, dabba by dabba y, dabba by dabba z. So just replace the values of f1, f2 and f3. So this is your f1, this is your f2, this is your f3. Okay, now f1 is this, so I just replace this here, f2 and f3. Now take the solve this determinant. You know how to solve this determinant, I as it is. Okay, now hide this row and column, so the cross multiplication of these two. Okay, now partial derivative of this z square minus xy with respect to y. There is no y here, so therefore this is 0. It's a this is 0 and there is a y, so x as it is, minus x actually as it is, and derivative of y with respect to y is 1. Okay, and now again derivative of this y square minus zx with respect to z. There is no z in this term, its derivative 0, and therefore minus x as it is, and z derivative of z is 1. So minus minus become what? Plus x. So similarly j as it is, minus j, and the cross multiplication of these two means derivative of z square minus xy with respect to x is minus y, and derivative of x square minus yz with respect to z is what? Plus y. And same here k as it is. Okay, and derivative of this y square minus zx with respect to x is minus z, and derivative of x square minus yz with respect to y is plus z. Okay, so as see here this x square is 0 and z as it is, derivative of y is 1, so minus z is there, like that, minus minus become plus. Okay, as usual, so you just see here minus x plus x is 0, minus y plus y is 0, minus z plus z is 0, and therefore your total answer becomes 0. Del cross f bar is equal to 0. As del cross f bar is equal to 0, f bar is what? Irrotational. This is for 2 marks. Okay, so up to this step you will get 2 marks, and the remaining 2 marks for scalar potential. Okay, now, so to find out the scalar potential, so one more note is important. This is not the part of example. Okay, so I just explain you, and we use this concept in the to solve the scalar potential. Consider this r bar, this is xi plus yj plus zk, and dr bar is dxi plus dyj plus dzk. I just take the derivative of this. Okay, now consider del phi dot dr bar. What is del phi dot dr bar? This is del phi I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z dot. What is dr bar? This is your dr bar. Okay, just I just take this, taken the same as in the previous step. Okay, so this is dr bar. Now this is the dot product of two, a1 b1 plus a2 b2 plus a3 b3. So this is dabba phi by dabba x into dx plus dabba phi by dabba y into dy plus dabba phi by dabba z into dz, and this is nothing but what? This is d phi. Okay, so this is d phi, Euler's formula. Okay, and but what is d here? Phi is constant here, so this phi is what? Phi is constant here, phi of xyz is constant, and therefore derivative of phi with respect, what is the derivative of phi? 0, because phi is constant, and therefore del phi dot dr bar is what? Del phi dot dr bar is 0, and therefore del phi is perpendicular to dr bar. We just use this here, del phi dot dr bar. Okay, to find the scalar. Now use the previous note to find out the scalar potential phi. D phi is, we know d phi is nothing but what? F bar dot dr bar. So we have taken f bar. This is your f bar. Okay, and now this is your f bar, and this is your dr bar. So this is dr bar. Okay, now the dot product of these two vectors once again, a1 b1 plus a2 b2 plus a3 b3, and therefore this is c. uh, Here it is x square minus yz into dx. Okay, and then y square minus zx into dy, and then z square minus xy into dz. Okay, now if you want find, this is derivative, so if we take the integration, this d get cancelled. Okay, so to find phi, take the integration, so integrating we get, so see, this is integration of this f1 dx plus f2 dy plus f3 dz. So now, but what is important thing here? So to find out the integration, first integration we should have to take yz constant. Okay, so in the second integration there is no x and z constant. Okay, and in the third integration, so there is no xy. So no xy means if the terms of xy are there, so skip them, don't take the integration of them. Okay, so same here, if x is there, the term of x is there, then don't take the integration, that the value of that term is directly 0, considered as directly 0. Now what is the integration of x square with respect to x? So this is x cube upon 3. Okay, so yz as it is, and derivative of 1 is x. Integration, sorry, integration of 1 is x. Okay, now the integration of y square with respect to y is y cube upon 3. Now x is here, see, we don't want x, but x is here, therefore its answer is what? Its answer is 0. So don't take the term, don't integrate the term which contain x. Okay, there is no x, so we don't want x, but x is here, therefore the answer is 0. Now here integration of z square with respect to z is what? Z cube upon 3. Once again x and y are here, therefore its answer is what? 0. Okay, and the constant of integration is there, and finally the phi is what? So your phi is x cube upon 3 plus y cube upon 3 minus xyz plus c. This is your phi, isn't it? So this is the method to find out what? Scalar potential phi. So every time you need to consider this formula. Okay, d phi is equal to a bar dot dr bar, Okay, if they in example they will ask to find out the scalar potential, you should have to take this result and then integrate. And in this, in all integration, you have to consider uh, these uh, conditions, okay, while integrating that both three integrations. Okay, now let us see the next. Show that the field f bar is solenoidal as well as irrotational. So solenoidal means what? Solenoidal means del dot f bar is equal to 0. So given f bar, okay, and so solenoidal means del dot f bar is equal to 0, and irrotational means del cross f bar is equal to 0. So just show them one by one. Consider del dot f bar. Okay, so del dot f bar is I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z dot f bar. So again, f1 f2 a1 a2 plus b1 b2, there is no c1. So that, okay, so j k, the term of k is not there, so its answer is automatically 0. So therefore dabba by dabba x of x upon x square plus y square, okay, plus dabba by dabba y of y upon x square plus y square. So it is u into v rule, so its answer is directly, you know how to solve that. Okay, I just taken this direct answer. So y square minus x square upon x square plus y square bracket square, plus the answer of this derivative of y upon x square plus y square with respect to y is x square minus y square upon x square plus y square bracket square. Use u upon v rule of derivative to solve these, to find these partial derivatives. Okay, so now see, if you see, denominator is same, take the addition of these two numerator. So minus x square plus x square becomes 0, and plus y square minus y square become 0, and therefore the answer is what? Totally 0. Del dot f bar is 0, and therefore f bar is what? Irrotational, sorry, solenoidal. So del dot f bar. Secondly, consider this del cross f bar. So I j k dabba by dabba x dabba by dabba by dabba by dabba z, f3 is 0, so therefore there is no need to take f1 f2. Again, once again, you know how to solve that. So I as it is, okay, I as it is, derivative of 0 with respect to y is 0, derivative of y upon x square plus y square with respect to z, as there is no z, the answer of this is 0. 0 minus 0 minus j, derivative of 0 with respect to x is 0, and derivative of this x upon x square plus y square with respect to z is 0. Why? Because there is no z in this term. Okay, plus k is there. Now derivative of this y upon x square plus y square with respect to x is minus 2xy in bracket upon x square plus y square bracket square, minus of this into minus 2xy upon x square plus y square bracket square. So this minus minus become plus, again this becomes 0. Okay, so again the answer of this is 0. So 0 plus 0 plus 0 become what? 0, and therefore del cross f bar is equal to 0, and therefore f bar is what? Irrotational. So just focus on the derivatives, because you have to solve the derivatives. So actually we, you know the procedure to how to solve the derivatives, partial derivatives. Okay, next example is show that the vector field is irrotational. Find the scalar potential phi such that f bar is equal to del phi. Okay, now we have the f bar. Now to show the field is irrotational, consider del cross f bar is equal to ijk dabba by dabba x dabba by dabba by dabba by dabba z f1 f2 f3. Okay, now so see here derivatives I as it is. Okay, so this I as it is, cross multiplication of these two, derivative of this minus xyz, minus xy sin z with respect to y is what? Minus x as it is, derivative of y is 1, and sin z is also as it is, see, minus x sin z, and partial derivative of this x cos z with respect to z, x as it is, minus minus become plus, x as it is, derivative of cos z is minus, and that minus become plus here. Okay, and derivative of cos is sine with respect to z. Okay, so x sin z and minus x sin z plus x sin z, this become what? 0. Same here, see, derivative of minus xy sin z with respect to x is minus y sin z, and derivative of y cos z with respect to z is what? plus sin z. And similarly derivative of x cos z with respect to x, derivative of x is 1, cos z as it is. Okay, and derivative of y with respect to y is 1 and cos z as it is, cos z minus cos z. This is again become what, 0. So all terms become 0 and therefore your answer is what, your answer is 0, as del cross f bar is 0. F bar is what, f bar is irrotational. Now come to the point scalar potential. As we seen that actually how to find the scalar potential phi such that f bar is equal to del phi. Consider this del phi is equal to f bar dot dr bar as usual in the previous example. So del f bar is equal to this dot dr bar. Okay, so again a1 a2 plus b1 b2 plus c1 c2, or a1 a2 plus b1 b2 plus c1 c2. Okay, now this is dot product of that two. Okay, and therefore after taking the dot product, so we get y cos z into dx plus y cos z into dx plus x cos z into dy plus minus xy sin z into dz. Now phi is equal to this, we want what, we want the d phi is equal to y cos z into dx plus x cos z into dy plus minus sorry xy sin z into dz. So we want phi, take the integration, so therefore phi is equal to what, integration y cos z dx plus x cos z dy minus xy sin z dz. So as usual we have the conditions x y sorry y z constant here, and in the first integration, in the second integration there is no x z constant, and in the third integration there is no xy. So y cos z as it is, derivative of 1 with respect to x is x or y xy cos z, and now x is there, therefore its integration is 0, because we don't want the term which contain x here. So because there is only one term and which contain x, so therefore skip that term, directly as 0. Okay, the answer of the integration. So same here xy, we don't want xy. Okay, so but here xy are there in the single term. Okay, so therefore we skip this term, we just directly write it as 0, and therefore only answer we get here xy cos z plus c, and therefore phi is equal to what, xy into cos of z. Next example is a show that del square in bracket r square log r is equal to what, 5 plus 6 log r. This is one more important question. So consider the LHS del square, this is a LHS as it is, I have taken that. Okay, so del square r square log r. So but if you see, we have the result for this del square f of r is equal to f dash of r into what, f dash of r in f double dash of r into what, f dash del square f of r is equal to f double dash of r plus 2 upon r into f dash of r. This is the very important result. Okay, so here f bar is equal to what, here f bar is equal to r square log r. See, del square f of r. So if we take the derivative of this first derivative, okay, because we just put the values of f double dash of r and f dash of r, so that we will get the answer. Okay, 5 plus 6 log r, we'll see how that answer we get. So f of r, take the derivative, f dash of r is what, again u into v rule, u as it is, r square as it is, derivative of log r is 1 upon r plus log r as it is, and derivative of r square is 2r. Okay, u into v rule I have used here, u into v rule of derivative. Now one r get cancel, and what I get, f dash of r is r plus 2r into log r. Once again differentiate. Okay, derivative of r is 1, 2r as it is, again u into v rule for this, 2r is u, log r is v, so 2r as it is, derivative of log r is 1 upon r. Okay, plus 2r log r as it is, and derivative of 2r is 2, because derivative of r with respect to r is 1, 2 as it is. So this r and r get cancelled, and finally we'll get 1 plus 2 plus 2 log r, and 1 plus 2 is nothing but 3, 3 plus 2 log r. So this is f double dash of r. And now see, using 2 and 3 in 1, so use this 2 and 3 in 1, what I get, LHS is del square r square log r, f double dash of r plus 2 upon r into f dash of r. Okay, now put the value. see here, 3 f double dash of r is nothing but 3 plus 2 log r plus 2 upon r. F dash of r is nothing but r plus 2 r log r. So take r common and cancel with this. Okay, so I just take r common and cancel with this r. So this r get cancelled. See here, this r get cancelled with this and this r. So what I get here, we get 2 as it is, 1 plus log r, 3 plus log r. So if we multiply by 2, okay, so 2 plus 4 log r we get, and therefore 3 plus 2 is nothing but 5, and 2 log r plus 4 log r is nothing but 6 log r, and that we want. This is our RHS. This is our RHS. Okay, this is simple. You need to focus on the results. Okay, so this is important result. Without this result, this is very difficult to solve. Okay, so just focus on the result and remember all that result that we are using to solve the examples. Next one is to show that this, what is here. So we have to show this del square a bar dot p bar upon r is equal to 0. Consider again same result we will use here. Okay, so del square a bar dot b bar upon r. Now a bar dot b bar is a scalar quantity. Okay, so there is no need to take inside the del operation, so take it outside. Del square 1 upon r. So as we know this result del square f of r. Now what is your f of r? 1 upon r. This is your f of r here. So f double dash of r plus 2 upon r into f dash of r. So what is f of r? 1 upon r. Its derivative minus 1 upon r square, and second derivative is 2 upon r cube. Okay, so you know these derivatives, and therefore what, del square f of r is what, substitute the values. Okay, so substitute the value of this f double dash of r here. Okay, in this result, and f of r here. Okay, so therefore 2 upon r cube, 2 upon r, and f dash of r. Okay, and therefore what, substitute here from 1. So a bar dot b bar as it is. Okay, del square 1 upon r is nothing but 0 here, and the answer is 0. Okay, now one more example is here. Show that this del cross a bar dot r bar is equal to 2 a bar. So it is LHS. So once again consider the LHS. A bar cross del cross a bar cross r bar. Okay, and now we know this scalar triple, sorry, vector triple product of three vectors, a bar cross b bar cross c bar. So a bar dot c bar into b bar, a bar dot b bar into c bar. Okay, so this is the vector triple product we use here, that vector triple product, and therefore what, del dot r bar, del dot r bar into a bar plus a bar dot del into r bar. So same product we have used here, same formula we have used here. So this is vector triple product. Okay, now what is del dot r bar? So this is 3, its answer is 3. We have seen this property, del dot r bar is equal to 3. Also we have proved this result, a bar dot del is equal to into r bar is equal to a bar. In the previous lecture we have proved this actually. Okay, so therefore we use that two values. So this is 3 into a bar, so value of this is 3, and value of it is a bar. 3 a bar minus a bar is nothing but 2 a bar, and therefore del cross a bar cross r bar is equal to what, 2 a bar. That's it. Okay, so in this way we have seen some examples regarding this concept. Okay, so I think you just understand this concept, so try to solve some more examples at home. Okay, so that you will be perfect in this concept. This is very important concept. Okay, and now so actually this unit is over here. We just complete this unit, and in the next lecture we will see the next part of this vector differentiation or vector concept. It is a vector integration, and in that vector integration we'll discuss the first part of the vector integration, and it is a line integral. It is very important concept in this vector integration, because the example is sure in the final theory exam. Okay, and now there are actually four concepts in this last unit, and they are line integral, Green's lemma, and Stokes theorem, and divergence theorem. So we will discuss one by one. Okay, thank you. So once again, if you like this video, just press the like button, and if you forget to subscribe, so just subscribe so that you get the intimation about the next videos. Okay, thank you.